Hello, and welcome to doing math problems with Desmos. And today we're going to show you how we can go through a Texas assessment of the STAAR and go question by question and see how many of those we can do with the Desmos online graphing calculator, a free tool, a free calculator available in desktop versions, available in iPad version, iPad iOS, available also in the Android system. This here is the iPad version, and I'm going to show the button right there. Opens up to the Desmos calculator, free. There is also a test mode that you may use, and there is also the iPhone version. Let's see, the iPhone version, and we have the test mode version also for the iPhone. And it's right there, test mode. And what I really enjoy about test mode is that you can lock the phone, also available in the iPad version. You can lock the phone, so what happens is that once you apply the lock phone, it's like the lockdown, like the lockdown browser, right? The student can't go anywhere. And you can apply this also to the iPad version, where the student can't go anywhere until he actually signals that he is going to leave the calculator. In any case, we are going to go through Desmos, and what you're looking at here is some artwork made in the Desmos. This is one of the top winners of the latest competition for Desmos Art, the art contest, the Desmos Global Math Art Contest. Here is the runner-up, second place, Jared Georgian Etienne from Massachusetts. And in first place was Ezra Oppenheimer with this stunning illustration of the Desmos place. So let us now go to Desmos and do the Algebra 1 STAAR assessment, Texas assessment that high schoolers take. And I guess we'll start with question number 1. And what I would like to do is to go through each of these questions and see how many of them we can do with the Desmos calculator, approved for use on Texas STAAR exams, but also exams throughout the state of Texas and throughout the United States. It is a direct competitor to the Ti-Nspire, a fantastic calculator, but this Desmos calculator, I must say, above all its attributes and its benefits, it is an absolutely free calculator for students to use. You are looking at, over here, what is called the Texas STAAR version. And let's start. What the students can do here, they can do on the day of the exam. Whereas in the version in the district's Clever account, there are no restrictions on that version, or the version that is freely available to anyone, and actually testing mode is available to anyone as well. And if students are used to using the Texas STAAR version, they'll be quite well prepared for the exam. Question number 1 asks us, what is the slope of this graph? And we start by entering the equation exactly as it is seen there into the Desmos testing calculator. So that would be the graph of y equals 12x minus 19. And we'll write that there, y equals 12x minus 9. You want to double check, you want to have the students double check and make sure that he's entering it correctly. That's actually minus 19. And I'm missing the x for the slope. This is standard slope formula. And on the Texas assessment of the STAAR, these are equations that are available to the student. The student does not need to memorize them. And here are the sheet of formulas the students will use or can use on the day of the test, both on the paper and the online version. So having read the first question, which asks us if or what is the equivalent, or what is the slope of this graph? Now, easy way to do that is to remember, and have the students, of course, remember that the slope y equals mx plus b, looking at it, it is the number, it is the coefficient of the x. Y equals mx plus b, it would be the m. Now, if students somehow forget, or perhaps they're not prepared to go in the day of the test, maybe we've got some newcomers that come in and aren't as prepared for the test, it may slip that's not the disconnect. There's a disconnect between the m value and what they're looking at in the equation. So teach the students, and I teach my students when I tutor them in mathematics, to put the slope formula, if given the equation with the slope, into Desmos. And we have done that, and we have gotten the graph that looks like that. Have the students check the coordinates. Desmos will identify them. Desmos will identify the coordinates, and the student may enter them and keep them labeled. And zooming in really helps, and there's your zoom buttons here. It gets completely out of control, come back home to the normal view. So we start with that, and these are the choices that are given. Students should be taught that the student, if they're asked what is the slope, to try each of them until one of them fits. And again, we see that if the student remembers that the slope is the coefficient, then this is a question that is complete quite fast. But in any case, having forgotten that, the student will enter the equation and substitute that coefficient. And let's start with -19. And the student gets that graph, that line, and it comes in a different color. And let's try the next one, -12/19. And the student will make a fraction. And you have to be careful over here how that fraction comes out. There's a fraction button. There's the keypad. Really want to have the students understand this keypad very well. There's our fraction. I believe there was a negative in front. 12/19. And we have that graph there. Okay, you don't see it. Well, that's when you use your zoom and say, where is that graph? Okay, there's that graph. That doesn't look like the slope that I have there. So let me make those disappear. We have this toggle button that allows you to see the graph and not see the graph and get it out of the way until we're done. And there's my equation. Continuing on, let's see the graph of 19/12 over, and we make a fraction again, clicking the divider, and that's 19/12. Still no match. Let that one go away. So we have one more, and we enter the slope, and what am I seeing? Substitute 12 for 12. Actually, that was 12. And what am I seeing? This graph and this graph are identical. So that doing a few of those problems helps to reinforce that that is the value of the slope. the m in the equation that they saw in their equation chart. Use that one. Paper tests may still be with us for a while, so go ahead and take that. And if it's an online computer test, then go ahead and enter that choice. So that was an easy one. And no, you didn't need the Desmos calculator to do it if you remembered that the slope is the value, the coefficient in front of the x in the slope formula given on the chart. In this one, I don't see that Desmos will be useful. It can be advisable for the student to plot the points. But in this particular one, it's a verbal problem that really has to be read carefully, and it's not really that difficult. I do have to say that as they are typed, it is not possible to get a value from these inequalities because the Desmos testing calculator, let's clear these away. The Desmos testing calculator does not do inequalities, and it will tell you that. It says the plotting of inequalities is disabled. So what do? Well, give it a good read and see what the question is asking us. So let us see this question. A golfer hit a golf ball from a tree box 6 yards above the ground. The graph shows the height in yards and the golf ball above the ground as a quadratic function of x. Students should understand what quadratic functions are going into the test. Okay, so we have this ball going over, creates this shape here. We have points, point. Now, the horizontal distance, it says here, the graph shows the height in yards of the golf ball above the ground as a quadratic function of x, the horizontal distance in yards of the ball from the tree box. So, reading here, what I'm looking at is the question asking me, the question is down here, the prompt, if you will. What is being asked? What is the domain of the function for this situation? So I think domain, and I think, oh, wait a second. Domain, the domain was, we've been taught, it is looking for an x value. So right there, we're taught that, well, if we're looking for the domain and the domain is x, then I need not concern myself with an equation that has a y. So right now, I'm down to 2 choices out of 4. From 4 out of 4, I have eliminated 2 choices. I now have 2 out of 4 choices. The chance of guessing it at this point is 50-50. So from between these 2 points in which I have an x, which one is most reasonable to choose? Well, I have a 0 here and I have a 230. Where do I see that? I see a 0 here, and it is in the place of the x in that coordinate. I see this number here, it appears here, and again, it appears in the x of that coordinate. So I have an x equals 0 here and an x equals 0 here. I have an x here, and I have a 0 here, my x in the middle, and 230. And I read, 0 is less than or equal to x, which is less than or equal to 230. So does that make some kind of sense? Well, is 0 less than 230? Right. At some point, could it be equal to 230? Well, we don't know, but it's reasonable to think that, or to observe that 0 is less than 6. So there's some truth in that. Let's look at these 2 numbers. We have a 6 and a 230. Well, where does that 6 appear? That 6 actually appears in this position, and it is a y value. So right there, that is suspicious. My 230 does appear in the x value, but we have something that doesn't match, doesn't add up. So what seems to be most reasonable to choose is that there is truth in that 0 is less than 230, and this statement 0 is less than x and less than or equal to x makes more sense. I would choose F. I look over here at my answer sheet, and we are looking. You can make a note of those student expectations, the TEKS there, and the correct answer is F. We now look at question number 3, and for this one, Desmos is highly recommended. We'll show you why. In this equation, it's true. Which one of these values make this question true? In other words, look at this. Which value of x makes this question, this statement true? Well, we teach the students to, through trial and error, try all of the options. So how do we do this in Desmos? Let's go to Desmos. And something that we should learn is that, again, as we stated before, the certain functions are turned off. So one of them is plotting the equations such as that. So let's try that. Go into here. It says there's your triangle. If you can't do this, it says plotting of implicit equations of inequalities is disabled. That's fine, because we want a value. So let's do this. We have learned that the Desmos does slope valuations. Disappear, and this works to give us a slope. Now, when we do these in Desmos, we're going to get a value that is going to, when we plug it in, one of these here, when we plug in one of these, it's going to add up to this. So the graph right now is not relevant. What is relevant is that you have a fantastic calculator right over here that will allow you to do the math. And we will use Desmos to calculate this same equation, or this math here, by changing this x into any one or all 4 of these until we get one that matches. Right? Or until we get one that makes the statement true, that is, equals this value here. So let's start with 3.5. I'll put that into my calculator. 4 times 3.5. Now I want you to get the students to, or if you're a student, get into the practice of having these parentheses in there. Okay, and I made a mistake right there because I should have erased that x. I put that back, parentheses, enter my value, and we get Desmos to do the calculation for us. 1.25 multiplied by what's in here. So what's in here, if you're doing this on paper, you would do this first. You would multiply these two out, subtract this, and then multiply by 1.25. Notice how quickly Desmos does it. You have a 5. And that does not make this statement true. So we go on to the next one, which is -1. So I go here, and I get my equation, and I type it a second time, and it's already set up. And I just have to plug in that -1 minus 1, or I can go to my calculator. There it is, -1. And notice, and I'm going to point this out throughout the assessment, that there are some differences from the Ti-Nspire. In the Ti-Nspire, you might notice that there is a separate button for negative or minus. And it gets a little confusing for students, particularly if they're new to the calculator or new to algebra. So in any case, there's only one minus button. It is there. and you plug that in, -1, and we get 17.5, and that is not the value that makes the statement true. That's not what we're looking for. So we go on and we try the next one. Write the statement again, and we go to our choices, and the next one is -0.5, and we'll put that into the calculator. And I'm going to put 0, is it -0.5, and I want to double check that. And I said, yes, -0.5, and does that make it true? No, it's not true. Okay, well, now we're down to our last one. We hope that that's going to be the one that's going to make the statement true. It's going to equal to that. So I go back to Desmos, there's a 4 there, and type out the statement again, and I'm going to replace that with the last value that I have, and that's a 4. Automatically generates 7.5. Does that make that statement true? It certainly does. There it is. And if I were to look at my answer key, look at it, question D, and that is correct. So we have used Desmos to solve the equation at 3, and all we had to do was to copy the statement, paste it into Desmos, and try out every value. Thank you, Desmos. We move on to question number 4 in this exam, and this asks me, which function is equivalent to the g of x equals x squared plus 15x minus 54? By the time the assessment is done, well, let's back up. The Algebra 1 STAAR is given in December normally, and it's a remake for the students that might have failed it the year before or the previous semester, meaning in the spring. Now, if the student finds themselves with this exam, and they may not have gone through a full semester of the full semester to, by the time they get to this problem, to understand fully quadratic equations. If we can teach the student, if we can teach you, if you're the student watching this, this is what your classic quadratic equation looks like. Simply take it as it is and type it into the Desmos calculator. And I'm cheating a bit, but see, I can get in trouble here because I copy and paste and the numbers don't match up. So you really want to be careful. So the g of x equals x squared, and I'm not getting my x squared, so I have to be careful. Something happened here, it shifts the 2 over, but we can fix that by going right next to that letter, make it a little bigger, and we're going to go to our keypad, which is down here, and see this a square? That gives us the square. Okay, now we should have fixed this over here, but I'm going to leave that for now, and I'm going to tell you what I'm going to do with that and ask you to do with it. Plus 15x minus 54. That's what our statement in the question asks us. Which function is equivalent? Which function is equal to this statement here, this equation here? So learn that that is the form of the quadratic equation, and where else do you see that? Excuse me. Where else do you see that? You see that in your chart. Let's go back to our chart. And it's the beginning of the exam on the paper, also available somewhere. Okay, so there is the quadratic equations. There's our functions. That's what it should look like. How does this help me out in the day of the test? Well, just remember, when you're taking this test, go back to the question. Back to the question now. We believe that was question 4. And 1, 2, 3, 4. And I'm going to see that one of these is equal to this. So first I put this into Desmos, and I'm going to ask you to do something. Yes, it will understand the function of x in that format. So g of x. Notice it understands it and it interprets a graph. All right. So we're going to use that graph to help us to prove that one of these choices, F, G, H, or J, is going to be the same graph as that. Because what are we doing here? We're factoring it out. So do you have to factor it out? It would be helpful if you learn how to do that, but we're going to let Desmos do a lot of the hard work for you. So back to our calculator, we have our statement, we have our equation, and what I'm going to ask is that, and you don't have to do this, but I don't like when it has that G and the parentheses and the X, and things get a little confusing. So I just say, remember that when it has a letter of X, a function of X, in whatever number, it's usually F of X, that you just remember that that's a Y. That's a Y, there's our statement. It didn't change anything in the graph, did it? But it just makes things easier to learn. Function of X means Y. Function of X means Y. G of X means Y. G of some other letter means Y. That format is your Y, and that equals this statement. And that means that this Y, this function of X, which means this Y, is equal to this statement. So one of these has to match. Let us now go back to our Desmos calculator and see one by one which one is going to be given to us. So let's start with the first one. The function of X, Y, is equal to these two factors. Let's go ahead and type those out. And it gives us, and now we have to be careful. Did we write it correctly? X plus 9, X minus 6. Okay, and we'll look at that, and if we have to zoom out, so no, it's not by a long shot, is it? We don't have the same value. We don't have the same size of the parabola. We don't have the same. We don't have the same coordinates. We don't have the same values. This is not the same parabola. This is not the same figure. Let's move on to the next one. So, function of X, or G, is equal to these two factors. So let's take those and let's enter those into the calculator. And did we type them correctly? Let's double check. X plus 18, X minus 3. So I have another parabola. I have another set of values. And let me take a look at this. Let me turn this one off. You have this circle here, and you turn it on, or you can turn the figure on or off. You can turn the graph on or off. You can toggle it, as they call it. And so let me turn that off. So what happened to this one? Okay, well, let me turn this one off. And oh, there it is. Okay, well, it certainly looks the same right now, doesn't it? So let's take a look, zoom out, and take a look at our figure down at the end, which is I guess it's called the minimum. And looking at that, and I'm going to zoom in a little closer because this can get tricky. This can fool you if you're not careful. Okay, there's that point there. Later on, you'll see that that's called a vertex, or if you might remember that by now. If you're watching this video, it's maybe just a review. And so that one didn't work. I'm going to leave that one out, but I'm going to put that one back on and turn this off. And that sure looks the same, doesn't it now? I could go ahead and I could quit right now, and I could say, you know, I'm pretty satisfied that seems to be the graph that I'm looking for. I'm even looking at my x coordinates, my zeros, and it sure looks the same, doesn't it? And I'm going to look at my last value here, which is my 0 here. Yeah, that sure looks the same, doesn't it? Okay, and I might be satisfied with that, and I might actually go to my test and I'm saying, you know what, I'm pretty confident that I'm going to choose that. So I go ahead and I choose it, and let me look at and on the day of the test, of course, you're going to bubble it in, but you might just want to check it later. But for now, you choose the answer, and then you're going to go and we'll let you know if it's right or wrong. So that was question number 4, wasn't it, right? Yeah, question number 4. And On our answer key, 4 is, there's your Teague, and G, let's see. Yeah, that's G. And Desmos does it again. I'm looking at a question and I'm seeing a table. Now, my suggestion to you is, if you're a student watching this, is go ahead and create a table in Desmos. I haven't read it yet, but I'm going to teach my students, and I'm going to ask you and recommend to you that even though you can go in a different direction here, and you may not actually need to create a table, I see a table, I've got hours for this exam just to make sure that my values are correct and that I can actually use the table to make me feel a little more comfortable with the choices that I take. I'm going to go ahead and I'm going to make this graph. And of course, I'm going to read it first and then do this table. So let me read it. It says the table shows the linear relationship between the average height in trees, in feet of trees on a tree farm, and the number of years since the trees were planted. Average tree height. And I have two columns, or two rows in this case. I have the number of years since the trees were planted. I have the average height. And we teach in the classroom, most teachers will teach, one will be an X, one will be a Y. All right? And so that is our information. We've got average height here, and average height is going to be our Y. You see that? Average height is going to be our Y. And let's see, on a tree, and the number of years since the trees were planted. Right there. So, okay, so let's take a look at that and now look at our question. What is the rate of change of the average height in feet of the trees on the farm with respect to the number of years since the trees were planted? There's a lot of words there. There's a lot of talk, and this is piled on top of all of this information that's been gotten. This is why I say it's a good idea to go ahead and create your table. And we're going to show you, if you haven't done this in Desmos before, how to create a table. It's pretty easy. But what we want you to know going into that test is that when you see this, if some of you have probably noticed, when we talk about the rate of change, we're talking about the formula for the rate of change, which shows us or gives us the slope. And if you have trouble remembering that, remember that this is one of those formulas that you are given on the exam. You're given this formula for the rate of change. And now, does it say, hey, formula for the rate of change, and you can do this with number 5? No, it won't. You just have to understand that this is part of our slope lessons. These are part of our slope lessons. And there is the slope of a line, and that question refers to the rate of change of y and x, y and another value of y, x and another value of x. The change in this y over the change in this x, the change in this y over the change in this x, and I'll zoom that up. And you are going to use this formula in your Desmos. But first, please, I recommend that you go ahead and put these numbers into a table, because, hey, they gave you a table. Maybe there's a reason that you'll use a table or have a table. So let's take a look at that. And mark that formula, and we'll get back to that formula. And as a matter of fact, yeah, let's do the table first. Back to Desmos, clear all this up. And let's get a new calculator. So I'm going to go hit this button. It has table. And again, this is the STAAR, the test version. So you will be able to do this the day of the test. And if I forget what these words mean, if I'm bamboozled by all of this chat, all of this talk, all of this information, then I'm going to create a table to try to figure out what's the relationship between this line and this line. And I'm going to plug those in. I said I'm going to make this X. So I'm going to plug those in as X. And it's 1, 3, 6, 11, 15. 1, 3, 6, 11, 15. You see how easy and fast that is? Okay. And then I'm going to go to my Y column. And I said, this is going to be Y over here. Keep getting in the way. Okay. And Y over here. 10, 24, 45. 80, 108. 10, 24, 45. Oops, I keep opening that up. All right, let's see. And that's 80 and 108. Okay, 80 and 108. We want to double check these because, you know, we're talking about 5 values here, 5 values there, 2 different columns. So let's check it, right? Okay, so nothing's happening. So that means we have to go to this and say, let's see, hold on to that, and I can draw a line here. All right, let's see. So we've drawn a line, and did that give us anything? Oh, it gives us a straight line, doesn't it? It gives us a straight line, doesn't it? Okay, all the way up there. A long straight line, doesn't it? Wow, it reaches all the way up to 108. See that? Okay. So there is definitely a relationship worth observing here. Okay. So let's go back to our question. And what is the rate of change? Okay, so maybe that will help me to understand. And as a matter of fact, what we teach in addition to the values for the formulas is that at some point, we teach the student, we teach you that you take 2 good points. You can take 2 good points. Let me draw a line here somewhere. Give me a line. We can take 2 good points that are on a crosshair, and we can actually find one that is okay up there somewhere. And let's try to find another line. Hold on a second. And it can get kind of tricky, right? Because you should really be careful about finding those points, all right? And it can get tricky. So, and then, you know, you've got this line, and what if we keep going and trying to find one that's exactly correct, and then we have to count these, and you remember that's the rise over the run, and which is okay, all right, so we'll just leave that for now. Try to work with this over here. And I think, well, all right, let's try the slope formula. And again, that's in your chart, and that's up over here. The change in y over the change in x, that is called the slope of a line formula. And let's work that, let's build that in Desmos, put that table to the side, put the graph to the side, put those boxes to the side, and type m equals, and then you're going to open up this keypad, you're going to have a fraction y1, oops, so y2 minus y1. You actually don't have to do this. You can actually just plug in your numbers right now. Okay, y2 over y. That's just, to me, this is just something that I would recommend for to remember the day of the test. This is what you're going to do. You're going to remember that I need to set it up like that. Set it up like that. And you got a triangle saying, hey, you can't do that. We need some values here. Well, you're going to get some values, but I want the student, I want you to have this actually there so that you can walk yourself through it instead of flipping back to the formula chart or writing the formula and getting your y2 not aligned to your x2 and your 2. So I'm visually looking at that, right? I'm actually looking at that. And remember, this is a web browser, so you can make these things bigger to accommodate your eyesight. You can make this bigger, right? And you can just, oh, this is too much. Back, please. Okay. So let's give it a little. Okay. All right. So I look at the chart. I don't have to look back at my paper, but maybe I want to make sure. So I want to, look back, or I've got my values in my chart now, right? In my table. Okay. So let me move this on along. Number 5. These are the choices that we have, and we're going to look at those. And let's get this done. So I'm looking here, and I'm looking here, right? And so these are my y's. So let's pick 2 points here, 2 y's. Let's pick, well, let's set it up, right? And let's see. So, and remember, you will not be allowed to do this equation with the m because this is a testing calculator. So, and some of you are used to doing this on the Ti-Nspire, and you can actually have one letter in the Nspire and in the it's called the we'll put it aside to that, but there is a function in the Ti-Nspire which I'm not sure if it's allowed, but you can do some of these functions in Ti-Nspire. We'll talk about that later when we hit a point at which I might suggest that you might want to have the Ti-Nspire on the side just to get, but let's try to do this in Desmos. Forget about that m for now. Let's just work on this fraction, okay? And let's take 2 points from here. Let's do a y2 over y1, and let's just pick the first, the ones at the bottom, okay? And so I'm going to set up my fraction, and I got that 108 over there, 108, it's y2, minus this 80 here, that's my y1, it's 80, okay? And I'm going to go here, and I'm going to, so now I need my x2, right? And I'm just going to make this one x2, 15, oops, the undo key, by the way, undo, undo. That's the undo, that's the redo, redo, undo. Okay, so here in the denominator, this is your x2 minus y, x1, see, it gets confusing, and I'm glad I have that there right open. So my x2 is going to be this 15 on the bottom, and it takes away 11. Okay, and I'm looking here, and all my values are positive, aren't they? Yeah, so we don't have to worry about that because they can get a little tricky if you're taking, if you have a minus value, but we're not dealing with that here. Oh, okay, well, I got a 7 here. I got a 7 here. All right, so let's see. Does that appear anywhere in my choices? And it says 7 feet per year. Now take a look at it and see if that's going to help you. All right, so I did this chart and I did this slope and I got this 7, and yeah, there's a 7. And now does that make sense? What is the rate of change of the average height in feet of trees with respect to the number of years since the trees were planted? What is the average height? Does it make sense to say that the average height is 7 feet per year? Okay, 7 feet per year. Okay, and I'm looking at this, and I'm looking at this, and 7 and 6, and there, and this is kind of, do I notice that 7 is somewhere in the middle? Yeah, maybe that'll kind of help. But in any case, I think we've got the information we need to answer this question. If you want to make sure, one of the things that I really insisted, you remember your rise over your run, or your fall over the run. So in this case, please go into that test remembering which direction is a positive slope and which direction is a negative slope. Okay, so right there, please go in there knowing that this is a positive slope. And if that's the case, then you can take 2 points, and let's 2 clean points, 2 clean points. And remember, you go all the way down here to get a clean point, and that might be it. And what's the clean point? And so let's try to, and this is just to confirm. All right, let's see. This looks clean, and this looks clean, and let's see if it is. Let's try to look at that. How do we know if it's going to be clean? Okay, and it's not. You see that? So we would have to you'd have to work on it. If you really want to make sure, you can go ahead on the day of the test to go ahead and do this. Right now, I think I'm confident that if I remember this formula, slope equals, remember, m equals this slope, m is the slope, equals the change in y over the change in x, and that is what my question is asking me. What is the rate of change? Okay, then I'll be comfortable the day of the test that my math has worked out. And Desmos did the heavy math stuff. Now, what about this table? Well, again, with 4 hours, if you wanted to go back and confirm, you can take 2 points that are clean, but I want to move on, and take 2 points and find the next clean point, and you can count. This is a positive slope, so we count up, 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 and then count 2 over. So if you count these and these, let's say that you have 14 between this one and this one. Let's say it's 14. And then you have 2, and then 14 divided by 2 is 7. And then we have a slope of 7, if that's how it's done. And again, I'm not going to get too much into that, but that is a way to confirm whether this answer is correct. All right, so let's take that answer. Take that answer. So everybody say 7, and we go to our answer key and try to confirm if we did it correctly. And that is question number 5, isn't it? Okay. Now we actually want our question number 5. You can take a look at the TEAG, and the correct answer is C. And the correct answer is C, 7 feet per year. We have seen that we have done 5 problems on this math test, and Desmos has helped us with 4 out of 5 of those. So if you do your math, 4 out of 5 would be 20, 40, 60, 80% so far of this test has been conducted using the Desmos. And I'm not saying that 80% of the work was done in Desmos, but 4 of these 5 questions, we've used Desmos to a large extent to help us arrive at the answer, or at least making the best decision out of the 4 choices that are given using Desmos. Let's use Desmos again on this one. So, question is, what is the equation in slope-intercept form of the line that passes through the points -4, 2, and 12, 6? I ask you again to use the graph in Desmos. Let's use Desmos for this. How we're going to use it, not exactly sure, but I see these 2 points and I want to make sense of them. Let me go clear my graph and go here, and I'm going to plot those points, and we'll show you how to plot them if you don't know how to do it yet in Desmos. Desmos is new for a lot of the students in my district. And let us go to the choices. Let's see. So again, the question is, what is the equation in slope-intercept form? If you forgot, remember that it is on your chart. It's given to you. You do not even have to remember it. Not on the STAAR anyway. Slope-intercept form means the classic y equals mx plus b. So let us actually go and put that into our graph. We're looking for something that looks like y equals mx plus b. Okay, it's telling you it's our triangle. Can't do anything with that, but that's okay. I want to leave it there so that I remember that this question is asking me, question number 6 is it? This question is asking me that in slope-intercept form, what is the equation? Okay, and it passes through these points. So I'm going to need to plot those points. So in my Desmos calculator, let me plot the first point. And that's -4, 2. All right. And I want to label it. And I can go ahead and I can put this other point on it in a different box, but please don't do that. If we're looking at an equation that runs through a certain point, then we want to visualize, we want to get a good look at what that line looks like. And the way you do that is by having both points on in the same box because we're going to create a line with it. And that's 12.6, isn't it? So let's do our parentheses. You can go to the keyboard for that. And here's your parentheses. And that was a 12, comma, 6. You don't even need a space on this one. And enter. And it says, hey, I couldn't do anything with that. And so, well, what's the error message? Okay, well, it's because I forgot something. These are 2 points, and they do need a comma in between them. And there you go. So where's that other one? Well, it's somewhere here. Let's zoom out. There it is. And it's hard to visualize. Let's get a line through it. Now, if you have the paper test and you're drawing your line, aren't you? And fortunately, Desmos makes it a little easier because you hold that down. And remember from, we had another question up above where we actually held it down. It gives us this little switch here, this little slide right, kind of like your iPhone slide right. And we now have a line. Now, I would like for that line to be all the way across, but you can't have it all. So we have a beginning point and an end point, and that's where they are, and I have that. And so I go and I look at this question again. Okay, I got this line, and so it says that the equation in slope-intercept form is of a line that passes through those points. Okay, so let's see. Well, trial and error, right? Let's take each of these as they are and put them into Desmos and see what I come up with. One of those lines is going to look very similar to that line there. I've got that line, and thank goodness I do. Now I have something to compare it with. So I go ahead and I say, what's that? What happened to my line? Well, let me see. Oh, wait a second. Let me turn this off. Oh, there's my line. Let me turn it back on. Let me turn it off. Let me turn it back on. You see that? Now, read the question again. The line that passes through the points 4, 2, and 12, 6. Am I seeing a line that passes through 4, 2, and 12, 6? Bam, we got that on the first one. Do we have to go on? Well, if you want to make sure, you could go ahead and you can graph all of them and make sure that you were on the right track, right? So let's go ahead and just for smiles and grins, we'll put this one here, this next one, just to show you that it might have been the last one. So then you just keep plugging it in until you find it. And there's y equals 0.02s. And look at that, it's actually parallel, isn't it? But does it run through it? No, it doesn't, all right? So that's not the line we want. This is looking like the best one, and you can go ahead and do all of them, right? And plug them into Desmos. And that certainly doesn't go through it. It goes through one of the points. Remember the questions it has to go through both. So we've already solved this question. So we're going to stop here. We're going to choose our answer, and that is right there, the very first one. Let us go to our answer sheet and determine if we've got the right one. Number 6, we can stop by and look at the T that it's testing, and it says F, the very first one. There you go. Well, that's 6 down and 50 something more to go. Okay. Well, fortunately, some of them don't take as much work, don't require as much work if you've got Desmos, right? Now you could use your TI calculator, but I am going to try my best not to compare the two. We'll leave that for another video. In this case, we take an equation again, and we just go ahead and plug it right into Desmos and see what we get. Which graph best represents the equation -5y equals -6x plus 15? Let's take that. Let's clear our calculator or clear our screen. That's all it is just to refresh it. And let's make sure we got it right. It's actually -5y equals -6x. Okay, -5y. Oh, I think we'll get totally wrong there. Must have had that from somewhere. -5y. Oh, -5y equals -6x plus 15. That might be a problem. Negative 5y, when we have a number in front of the coefficient, that gets tricky. See, it's already getting messy. Negative 6x plus 15, let's get that down. Negative 6x plus 15, that's in slope-intercept form. And I thought, nothing's happening. Plotting implicit equations is disabled. What am I gonna do now? What am I gonna do? Well, this is going to work somehow. And so what we're going to have to do is we're going to have to put this in standard slope-intercept form. And what is that? We go back to our chart, and standard slope-intercept form, remember, is y equals mx plus b. So it's got to look like that, right? So how can I make that look like that? You will be taught or have been taught that you have to get y by itself. So let's do that. Well, let's get the y by itself. How do we do that? We teach you to cancel out that, whatever is with that y. So how does that cancel out? Well, we divide the negative 5 by the negative 5. And you can do this on your paper. Negative 5 by negative 5. Okay, I really don't want to work on paper, but if I have to, I would. And that would require getting the scratch pad. Let's see, let me take this pen over here. And remember, that's negative 5 divided by negative 5y divided by negative 5. We cancel those out. That gives us the y by itself, right? You see that? Oops, what's going on here? There you go. Y by itself, yeah, we've canceled it out. Negative 5y divided by negative 5y. Okay, that's actually a 5. It was a 5, they're gone now. And I got my equation now, I'm set, I'm halfway there. So what you do on one side, remember you have to do on the other. So I have to take this over here, it's negative 6x, and I have to divide that by the same number, 5, right? So, okay, now I can try to do this, but remember it doesn't do equations. I could try to do this in Desmos, right? So 4y equals something. Let's leave that, okay, and divide that by, I can try to divide that, which is my division. All right, okay, messy there, right? All right, so let's see. What I need is to divide that by negative 5, right? Okay, and it's giving me a value here, isn't it? All right, but it's not giving me that x plus b format. Okay, so it's giving me the line, but it's not giving me that x plus b format. So let's go ahead and get that. Let's do the math, right? Let's do the math one by one. So negative 6 divided by negative 5. And I can do that on my calculator. Negative 6 divided by negative 5. Excuse me. Negative 6 divided by negative 5. Okay. We get 1.2, right? So let's see. So I got what? 1.2. All right, let's put that 1.2x actually, right? 1.2x. And so negative 5 into 15. Let's do that. Let's see, I have another fraction. It's getting really messy, right? Isn't it? So we have a positive 15 divided by a negative 5. Okay, and that gives us a negative 3. So we have 1.2 plus negative 3. All right, let's see. And enter. Okay, and it's giving us that line there. Okay. So that's the same value, right? Yeah. So what it did was it calculated this ugly fraction is the same as calculated, and I'm going to write it out. I'm going to write it out because what I want to show you exactly what we're doing. We're taking this fraction here, right? If you standard textbook as we were taught, let's see, yeah, on that side we had negative 6x plus 15 divided by negative 5, right? And so negative 6 over negative 5, right, gave us our 1.2, right? And then this negative 5 into 15, it goes 3 times, right? It goes 3 times. So actually go negative 3 times. Negative 6x, this is 1.2, I guess. That's what they tell me the fraction is. And here's another neat feature. Now that you're here, see this? It gives us different ways of calculating that. And it says, and notice it says, that's actually 6/5, because a negative over a negative, right, becomes a positive, right? And there's our decimal. Whew, okay, really ugly stuff. So I'll just leave that there and just know that this equation has now become the graph of y equals 1.2x plus negative 3. Okay, all right, and that's actually just negative 3, right? Let's make this neater. Negative and a positive is negative. So that's what it is. One. Yeah. I noticed it didn't change anything. You see that? It's the same graph. All right. So not straightforward, is it? You have to learn and remember how to get that y by itself. And this ugly bit of math is how you do it. Cancel out, get the y by itself, and do that math. But as you can see, Desmos can help you out with this math by letting you see that the ugly fraction of negative 6x over negative 5, it actually gives you the result, and it remember your x, and then remember this bit of simplification just gives us a negative 3. Put those together, it gives us that line. Whoa. Let me clear all of this out. Just make a mental note of that. Take note of that. Write it down somewhere. I'm going to clear it because it is getting a little confusing. I'm going to take this one here. I'm just going to put that up there. We can move these, right? Okay, I'm going to just put this one over here, just to let you know how we got that. As a matter of fact, just to not, yeah, I'm just going to leave that there so you can see where I got the 1.2. We got the 1.2 from. Whew. Now, and then I'm going to get rid of this one because we have it up here. Get rid of that. All right. We now have it in standard slope point formula. We go back to our question and say, well, how does this help us? Which graph best represents any one of these lines? Let's take a look at what we've got here. We want to zoom in. Okay, looks like we have 2. We have the 3 here, right? Now we have to 2.5. Yeah, notice it. And then this one here is 2.5. No, it's a 3. It's a 2.5 and a 3. Okay. All right, it's a 2.5, 0, and a 3. Okay, and those are our coordinates that hit those axes, and that might be important, right? Let's see. I'm gonna mark those down because I have the time to do it. 2.5, and then 2.5, 0. 0.5, 0 is 1, and then the other one is negative. It says right there. I don't have to guess. 0 and negative 3. And I just want to mark them so I don't have to keep going back there and identifying. Negative 3. Thank you. All right, that's 2 points. All right. So, okay, I go to my paper or my graph online. Now, if you're doing this on a computer, you should have a zoom in function. Okay, we happen to have this on a computer. We have a zoom in function. And first of all, notice that the direction of the graph goes up to positive slope, so we should have a positive slope. So that's a good sign, right? 1.2x is positive. There's no negative in front of it. We canceled that out. We got a positive. Okay, so that's a good sign. So you want to therefore understand that the direction of the graph is important, right? So that means I can actually go ahead and say that's a negative slope, that's a negative slope. We don't want those. Let's take a look at this. All right, look where this graph is. Look where this line is. It's over here in this, what they call a quadrant. It's over here. So we don't want that over there because we just determined with all that fractioning, right? All that fractioning, if that's a word. With all those fractions that we did to get y by itself, we find out that our line actually falls here, right? I guess. All right. And it's got a 2.5 and it's got a 3, and you could do your rise over the run, but with those points, it would be difficult, or it would involve putting its decimal in the denominator, and maybe you don't want to do that. Or you could go ahead and find a good point somewhere up there. You could do that to verify. For now, I think I'm comfortable enough knowing that it's here is in this quadrant, right? And it looks mostly like that, like this graph here, right? Where the slope is up to the positive. It looks like it's hitting the 2 point something, and it looks like it's hitting the 3. That's the closest we can get. Again, if you have a paper, I would insist on having a magnifying glass if they let you use that the day of the test, to make sure. And hopefully you won't have a paper test. And hopefully you'll have Desmos to do that basic math, the division, the canceling out, and all of that stuff. Go down, down, down. I think we're going to work with that. So that is C. And what does our answer key say? Take a look at that. And this is, what question was that? Question number 7. Did we do 6? Do 6? Yes, we did 6. 7. 7 gives us, reveal it, is our teak, C. And Desmos does it again. Well, you did a lot of work that time, so pat yourself on the back. We move on to this question, which asks, a baker determined the annual profit in dollars from selling pies using P of n equals 52n minus 0.5n squared, where n is the number of pies sold. What is the annual profit if the baker sells 400 pies? So you're given a lot of information. So the annual profit, you'll have, many of you will have a dictionary the day of the exam. If you have a dictionary and you forget something like the word profit, it will say something like money. You'll say, okay, money, so we're dealing with money, right? We're finding out about how much money, okay, how much money. So the baker determined the annual profit from selling pies. So he's selling the pies, he's making money using this formula, okay? So, and remember what I said, this gets a little ugly, you know, this function of n, function of x. Let's just make it a y. And whenever you see something this set up like this, please just make it a y. A y equals 52n minus this number squared, okay? And it says, it tells me n is the number of pies sold. Is equal. Is means equal, usually. Usually means n equals pies sold. N equals pies sold, okay, normally. What is the annual profit? What are they asking? What is the annual amount of money? What is the annual amount of money if the baker sells 400 pies, and that is a big one. It's telling us the baker sells 400 pies. So how much money does he make if he sells 400 pies? Well, let's see. A baker determines that the annual profit, what he makes every year, is this here. Y equals this, right? So Y equals this this should figure into this equation, right? Okay, so let's take a look at, let's take that equation. Let's go to our debt. Let's do this. What are we going to do? N equals, N is the number, and okay, we have a connection here. N is the number, it equals the number of pies sold. N is, it equals pies sold. N equals, can you see that? 400 pies. N is pies sold. Baker sells 400 pies, and baker sells N pies. Baker sells 400 pies. N equals 400. This is where the scratch pad is useful, right? So go ahead and just remember that. And I'm going to just make a note of that. N equals 400. In fact, I could have it on a scratch paper, or I could just go to my Desmos and make some scratches. N equals 400. Okay. Yeah, N equals 400. All right. And I'm looking for one of these numbers. Okay, we also have a, let's see, we also have, yeah, N equals 400. We also have this formula here. This formula here goes into here, and make sure you type it correctly, right? Okay. All right. Oh, okay, I see what it did. Hold on a second. This is something that's actually new to me. Let me clear this. It says, it's got this value here. Get this value here, and then it's got Y equals, oh, okay. Look at this. I have to admit, this is new to me. I didn't intend it. I just wanted to use this as a marker. See that? It's N equals 400. And in this equation, it says, I realize that you put a value into N. Now, and again, this is not to compare in this session, in this video, what you would do in another calculator, which at this point I'm just going to remain nameless, where you actually have to set up the values, and it could be a chore. Here it just did it. I didn't even ask him to do it. It's N equals 400 according to my values right there. Okay, and I said, let me mark that spot in Desmos, N equals 400, and then let me put this equation, and the equation said, I notice you got something in N. Let me take that, put it in here, and give you this calculation, okay? So let's do this. Let's just play around with it. What's half of 12,800? It's 6,000 something, right? So if the number of pies was 200, look at that. Yeah, it actually responds to the number in N. It's given N a value, right? And what's 1/4 of 12,000? Probably 3,000 something. Okay. Okay, 4,700. Okay, all right. 1/4 of 400 is, okay, 40. All right, you get the idea, right? But really, N equals 400. So now you know, you can put a value in N. I haven't been teaching that, but you know, it's something to know. All right, and look at that. Desmos immediately calculated for you. Let's see if that appears in the choices. 12,800. And does that make sense? The annual profit per year is this amount of pies. And does that make sense that he would make, okay, and from 400 pies, 12,800, let's see. Well, it's not exactly 400 pies. It's 400 times all of this stuff. And the 52 is probably the 52 weeks. And this is probably a certain amount done per week, right? And then multiply those out. But the point is, N equals 400. And you plug that in. it gives us, Desmos rapidly does the math to give you the number. We choose to take G here. Let's see if that's correct. Let's take G, bubble that in, check our answer key. 8 is G. G, that works. In this problem, the graph is created, it's presented. Look at the graph, and you're told an exponential function is graphed on the grid. That's what you're told. So what do you do with this? Well, the question asks you which function is best represented by the graph. And you're given 4 choices, and it's pretty much asking which of these looks like this graph. So let's go ahead and plug them into Desmos, see what we get. So you're given this graph, and let's hope that as we put these in, that we don't have to play around too much with these numbers. Okay, look at that, and again, my advice to you, we can put in g of x into Desmos, it will understand that. I want to get away from that if I can, and I want you to get away from that if you will, because I don't like I don't want to risk the chance that someone will confuse that as a g multiplied by x. It can happen. So just to be on the safe side, g of x only means y. And let's type them in like that. So I go to my Desmos calculator, and I type, let me clear this out here, g of y equals 6 in the first one. I'm going to try each of these to see which one matches this graph here. Y equals 6 multiplied by a third. 6 multiplied by, and I have my divider sign. My division sign will give me my fraction, 1 over 3, and it's got the closed parentheses, or you can type it closed parentheses. Now, in this case, this is not a square. It is some exponent represented by x. I hit this a to the b, and it gives me a space where an exponent would be, and I can put whatever I want there. In this case, I'm going to put an x, and I have x and y on the main keyboard, and you can put any letter you want, right? They're over there, but the main ones, x and y, are right there in the very first 2 keys. I'm going to put an x. There we go, and make a note of where that graph lies. Okay, and again, I can see here, I can put these points here if I have any doubts. I can go back here and I can put those points there. For now, I'm going to move on to the next one. Okay, so I'm going to, since they look pretty much the same, instead of writing those all over again, I'm going to copy and I'm going to paste that and change the numbers a little bit. And that is my g of x, or y, equals 6 multiplied by a third to the x. So all I have to do is multiply by, change that into a 3, okay? 6 multiplied by 3 to the x. And what do I have there? And again, I'm comparing that to these over to this graph here. I want something that looks like that. I'm going to open this one up a bit, and it might help if this is on paper. If you're still doing a paper test at the time, it might help to have a magnifying glass. And I'm not sure what the policy is for that, but you might want to ask. I know that sometimes these graphs can be pretty small. Okay, so I'm hitting a 6 here, and I'm hitting something that looks like a 4 there. And so far, I'm hitting a 6 here, and I'm getting pretty close. I'm not actually hitting the 4. Okay, not exactly sure, but I know this is not the direction I want to go, right? So let me get rid of that one for now. And I'm not deleting it, I'm just making it disappear for now. So let's look at the next one. It looks familiar. It is g of x equals, and it's pretty much the same one. I'm glad I copied and pasted it, copy it, and I can paste it, and all I have to do is a negative. I don't have to do all of that. I put this off to the right. That gives me space for my negative. Okay. Now what do I have? It's a green one, right? So where is that green one going? Let's see. Did I have to press enter? Okay. All right. Where is that? I don't see anything. I keep go down, zoom out. Where did that go? I don't see it. Okay. Well, what happens normally when we can't see it? It's hidden somewhere. It's usually hidden under somewhere, right? So let's see. All right. Is it hidden under here? Okay. No. Okay. All right. So it seems to be off somewhere. Let's keep zooming out until we find it, right? See it. So maybe we'll just have to get back to that, right? Oh, keep zooming out, and I don't see it. Okay, got to be a reason for that. Okay, back in. Actually, I can just hit that. All right, let's see. What did I do wrong? Make sure I got this right. I got this exponent here, right? And exponent of x. All right, so I'm trying to figure out where that y left. Let's do the next one for now. And let's see, the g of x equals 6 minus 3x. And it's pretty much this one here. So let me just copy and paste this one here. Minus 3x. Okay, right there. Okay. And let's see. It's just a point. Let's see that. Okay. Just a point, isn't it? Oh, okay. Let's see this one here. Let's take a look at this one here. And then we have a negative here. And negative. And then what I'm noticing is when this is negative, they disappear somewhere. I don't see them. Yeah, I don't see them. So that's kind of weird, but I'm getting the point. I'm getting this point. And that is very odd. Let me turn this blue one off. And the only thing I'm left with is that point. And that doesn't look like a graph. Okay, we'll turn that one off. Turn that one on. And what point is that? Okay. I don't even see that. See that? That is weird. But hey, there's got to be a reason we don't see it, right? We just see the dot. Usually we see the coordinate there. And then this one, which looks very much like it, like it's a negative to an exponent, is not giving us something that we can see on this graph, even if we zoom out all the way out. And there might be a point somewhere off there to the negative, but we don't see it. Okay, so what do I have left? Let me turn that off. Turn this one on. That's not working for us. Turn this one on. Okay, and that one's working for us. And again, if we zoom in, that's kind of the home button. That's kind of, close. 4, and then if we definitely hit the 6 here, and I guess we can zoom in a little more. And it's not exactly, it's kind of hitting that 4, but it does. The question is, which function is best represented? So the best one, to the best of our ability, is the one that is at A. It's the first one. We're just going to have to accept that. And oops, it's yeah, let's get that one there. And see if we're right. There's our answer key. That is number 9. And it's A. Yep. Close enough. Thank you again, Desmos. What is the equation in slope-intercept form of the line that crosses the x-axis at 36 and is perpendicular to the line represented by y equals -4/9x plus 5. Well, good news, because I'm seeing that this is standard form. I don't have to do anything to the y. I don't have to cancel out. I don't have to bring over. I don't have to divide. That is a good format for the slope-intercept. So I'm going to take, and then I'm going to read carefully. And what is this question asking me? So what's the equation that crosses the x-axis, crosses the x-axis at this value, and is perpendicular? So that's another important piece of information. And again, if you happen to be allowed to use a dictionary and you forget what this word is, I would look it up. But if you look it up, you should be able to remember that we use perpendicular values when we talk about angles, right? I'm trying to get us, oh, I have my straight line function here. Do that. It should be a nice straight one right there. So we have perpendicular when two lines cross at 90-degree angles. And we'll cover more of that in geometry, but if you've seen some of this, remember that perpendicular cross at this very perfect angle, 90 degrees. Okay, so it's got to be, when we plot these lines, each of these, one of them is going to perfectly hit this other line, which is here in your equation. So let's start by putting that into Desmos. Calling on Desmos again. So it's just y equals, and then we have our keyboard hit the divider for a 4/9. I think that was positive, right? So when that happens, you bring it out here, you do your plus, and 49 plus 5, 49x plus 5. Don't forget your x. 49x plus 5, or otherwise it won't work. Okay, so immediately it draws a line. So that's our given line. All right, that's our given line. And bring it down and bring it out. And that makes sense. It's a positive slope, positive direction, 4/9. So now we just have to enter each of these lines, as we did before, until we get a line that matches. Not hard, right? You're an expert at that now. So here's my line here, and it says 4/9x plus 16. Well, let's take a look at that. And, oh, by the way, you might want to remember a few points so that you don't have to do this every single one of these. You might want to remember, in my options, are there any negatives in front? Well, there are none, which means that we can't eliminate based on the fact that we have a negative slope. They're all positive. But one thing you might want to remember about perpendicular slopes? Well, we'll go over that later when you observe what the end result is, and I'll ask you to remember that for the future. In any case, we're going to put in our next value, and it's pretty much the exact, it looks like the exact same equation. Well, let's start A, right? And, excuse me, have that in there. Okay. And the first one, A or F, is plus 16. Let's take a look at that. Okay. And so it's running alongside this line, and we call that two lines that are parallel, and that's not what we want. Okay, but I'm going to take this and I'm going to put it over here, because the only thing I have to change is the value there of that b-intercept, that second number out there after the mx, and change that to a negative. And what do we have? Okay, well, I don't see it. Let's go find out where that is. It's down here, and it is another negative, and I mean, it's another parallel. Parallels are not perpendicular. Remember what we want for the perpendicular? We want this kind of line, right? want that kind of line. Okay. Okay, so that's not it. So we go back and we enter another one. So we have totally different values here. We have 9/4 plus 81. So let me go back here. I've set this up to, we have 9/4. We invert that fraction, 9/4. And we have a multiple of 16, and that's 81. So that goes out there. But is it perpendicular? Perpendicular. You can zoom in. Sometimes your mind plays tricks on you and you think, yeah, is that perpendicular? You know, that kind of looks like an acute and an obtuse. It doesn't look like they were really crossing at 90 degrees. We'll put that to the side for now. We got one more to go. Is it gonna work? Okay, so we have pretty much the same one. I'm gonna copy and paste and just change the sign. All right, and this becomes a negative. All right, enter. Okay, and what did I leave out? I left off the Y. Okay, down, down, okay. And where did it go? Oh, there it is. There it is. Wow. And I don't think that looks like it's perpendicular. So what do we do? Where do we go wrong? Let's make sure these are all correct. Okay, so y equals, okay, so our original is y equals -49 plus 5. And go, see, our original one is wrong. Look at that. Big mistake. We were wrong, well, I was wrong, coming out of the starting gate, because that's a -4 nines. You say, well, it's got to be one of these, right? Okay, well, let's get that right. -4 9. Oops, -4 9. Okay, there we go. -4 9. Okay, and now we look, something's perpendicular there. And is it the first one? No. Is it the second one? No. Is it the third one? Yeah. Look at that. Third one. So take a look at the third one. Yeah, that could be a perpendicular. So now we have two perpendiculars. But what does the question ask us? It asks us that in addition to being perpendicular, there's something else. It crosses the axis at 36. Did you see that? Okay. Crosses the axis at 36. So which one of these crosses the axis at 36? Let's see. We have, let's take a look at this one here. Where does it cross? So it's perpendicular. It sure looks that way, right? Okay. And 35, 36, sure enough, that one over there crosses the axis at, wait, whoa, back up. Okay, crosses the axis at 36, yes. And I was about to get giddy and think, oh, there it is, but what did I do wrong? I jumped the gun. I said I was getting happy because I saw 36, but in fact, that's not 36. It's -36. See, good thing you stopped me from choosing an answer, because I'm looking at that one and I'm looking at, this is the x-axis. We know it is because there's 0, 0. There's my x, okay? And it crosses that line that we drew is perpendicular to our given line, and it crosses the x-axis at 36. We count them. All right, and that's going to do it for that one. So that, I guess that was what, J? Yeah, that was J. So we wound up having to do them all anyway, right? So we didn't lose a whole lot of time there. And choose J. Choose J. And confirm that over here. That was number 9, I believe it was. And wait, oh, what number was that? That was 10, excuse me. That was 10. Oh, okay. 10 is J. Yeah, J. 10 is J. 10 is J. There you have it. 10 questions. And out of the 10 questions, we used Desmos for, I believe, 9 of them. Now, one of them required some good head thinking that was a part of the canceling out, all that kind of stuff. But we did use Desmos to help us with the division and the getting the signs right. So we did use Desmos. We used Desmos in 9 out of the first 10 questions. That's 90%. That's 90%. And in some of them, like this one, Desmos does most, if not all, of the work, because you're able to just put the equations in and just let Desmos tell you whether the graphs match or they don't match.